This is Mr. Erlin demonstrating the review packet for Unit 7, Polygons and Quadrilaterals, Spring 2021. What is the formula for the sum of the interior angle measures of a polygon? Well, the sum of the interior is equal to n minus 2 times 180, where n is the number of sides. What is the formula to find the measure of each interior angle of a regular polygon? So if it's regular, then that means this sum could just be divided by the number of sides. So a single measure an angle is equal to n minus 2 times 180 divided by n in a regular polygon. Find the sum of the interior angle measures of a 35gon. Well, the sum would then be 35 minus 2 times 180, 33 times 180 equals 5940 degrees. 6 angles of a heptagon. Heptagon is a 7 sides. Measure 107, 139, 131, 110, 145, and 128. What's the measure of the 7th angle? Okay, so I know that all these together add up to the sum of the 7-sided polygon. So I'm going to say 7 minus 2 times 180 equals 5 times 180 equals 900. So all of these added up, 107 plus 139 plus 131 plus 110 plus 145 plus 128 plus x equals 900. So 107 plus 139 plus 131 plus 110, 145 plus 128. This whole sum comes out to 760 plus x equals 900. Therefore, x equals 140 degrees. The sum of the interior angles of a polygon are 3,780. How many sides does it have? So that means n minus 2 times 180 equals that big number. Divide both sides by 180. 3780 divided by 180 gives 21. So if n minus 2 equals 21, then n equals 23. That's a 23-sided figure. What is the measure of each interior angle of a regular 18gon? So I could say the measure of the angle is equal to 18 minus 2 times 180 over 18, which means 16 times 180 over 18. This one happens to reduce nicely because the 18 and 180 cancels in the bottom, leaving 16 times 10. So it's 160 degrees is the measure of a single interior angle of that regular polygon. What is the sum of the exterior angle measures of any polygon? Well, that's 360 degrees for any polygon, which means for a 30-sided gon, it would just be 360 divided by 30, which is 12. If the exterior angle of a regular polygon is 24, how many sides does it have? Well, 360 divided by the number of sides would give me the measure of an exterior angle. So in this case, that would be 360 divided by n equals 24. I can cross multiply and solve, and I get 24n equals 360, which means n equals 360 divided by 24, which is 15. Not degrees, it's the number of sides. If the interior angle of a regular polygon is 162, how many sides does it have? I could use the interior angle formula, but I'm going to go an easier way. I'm going to say that if I know that the interior angle is 162 degrees, then I can find the exterior angle by doing the supplement, saying 180 minus 162 is 18. And if that 18-degree angle is the exterior angle, then I can use this idea over here. 360 degrees divided by 18 degrees for each one tells me that there's 20 sides. For number 11, it's asking us to recognize that all of these angles together add up to some number. I need to figure out what that is. If there's 1, 2, 3, 4, 5, 6, 7, 8 angles, that makes us an octagon. So n equals 8. That means that the sum of the interior is equal to 8 minus 2 times 180, 6 times 180, is 1080. So that means all of this together adds up to 1080. So 139 plus 10x minus 11 plus 121 plus 9x minus 17 plus 7x plus 6 plus 153 plus 9x minus 14 plus 8x plus 15 equals 1080. So I'm going to combine the constants first. 139 plus 121 minus 11 minus 17 plus 6 plus 153 minus 14 plus 15. So that total is 392. And I've got 10x plus 9x is 19, plus 7x is 26, plus 9x is 35, plus 8 is 43. So plus 43x equals 1080. Subtract the 392, and I get 43x equals 688. And if I divide 688 by 43, I get 16. X is equal to 16. If the figure is a regular polygon, solve for x. Okay, so a regular polygon, 1, 2, 3, 4, 5, regular pentagon, would have 5 minus 2 times 180 over 5. In other words, one of those interior angles should be this. So 3 times 180 over 5. 180 times 3 is 540, I think. Yep, is 540 over 5, so that's 108 degrees. So this single angle should be 108 degrees. Subtract 31, and I get 77 equals 7x, so x equals 11. Last one, these are all parts of the exterior angle sum. In other words, all these together are going to add up to the exterior angle sum, which for any polygon is 360. So 11x minus 5 plus 4x plus 29 plus 61 plus 6x plus 13 plus 9x minus 15 plus 67 equals that total of 360. So 11x plus 4x is 15, 21x, 30x. 29 minus 5 is 24. Well, let's do this. 29 plus 61 is 90. 103 minus 20 is 83. Plus 67 is 9150. So 30x equals, subtract that, I get 210. X equals 7. So if this is a parallelogram and EB is 16, then I know that CD is also 16. And if ED is 25, then I know BC is also 25. And if BF is 11, because the diagonals are bisected, I know that FD is also 11. They didn't ask for that. And I know if EC is 34, that gets bisected, so these parts are each 17. Did they ask for EF? No, CF. FC is 17. And BD is double that, because if each is 11, then the total is 22. Then in terms of angles, they're telling us that BED is 55. And that tells me that EDC, which is a supplement to that, 180 minus 55 is 125. EBD. Okay, that's going to need something new. Let's see what else we got in here. They're telling us that CDB, this one is 67. And because of alternate interior angles, that's also 67. EBD, that's what they asked for, 67. BEC. Well, let's see about that. Oh, they told us that BCE is 24, which means this little part is 24. So BEC is the difference between those two. 55 minus 24 is 31. So that's 31. And then DBC. Well, if this entire angle, DBC, if this entire angle, as we said previously, is 125, and that's part 67, we can say 125 minus 67 is equal to 58. So this part must be 58. Okay, now we're looking at parallelogram. Assumedly, opposite angles are congruent. Therefore, I can say that 8x plus 17 equals 12x minus 39. Subtract 8x, add 39, 40, 56 equals 4x. X equals 10, 14. Which means I need to find one of these angles. So measure of angle K equals 8 times 14 plus 17. 8 times 14 is equal to 112 plus 17, which is equal to 129. Now if K is 129, N has to be the supplement of that. So 180 minus 129 is 51, so N must be 51 degrees. Okay, they're going to do it to us again here. Let's see, these two are consecutive interangles, so they're supplementary. So 5x minus 6 plus 14x minus 4 equals 180. 19x minus 10 equals 180. 19x equals 190, so x equals 10. That means that measure of angle T, 14 times 10 minus 4, so that's equal to 140 minus 4 is equal to 136. Since measure of angle R equals measure of angle T, we can say that R is equal to 136 as well. Number 17, it is a parallelogram, ABCD. If we know that ED is 7x minus 13 and BD is 16x minus 38, what's that relationship? Well, I know that whatever length ED is, twice that would equal BD, right? Whatever length this is, if it's 5, then this would be 10. So with that algebraic setup, I can then solve this by plugging in or substituting and solving. Subtract there, add there, so 12 equals 2x, x equals 6. We're looking for BD, so we should plug it into that. So BD equals 16 times that minus 38. We know that that's 6. 16 times 6 is 96 minus 38 is equal to 58. So BD is equal to 58. Next, we're looking at a rectangle. We know that if AD is equal to 9, then BC will also equal 9. And we know that if AC is equal to 23, then BD, the opposite, the other diagonal will also be, 22, will also be 22. And we know if AC is 22, then AE and EC would each be 11. And let's see, we need AB, huh? So if this whole length is 22. And this is 9. Then we've got a right triangle because this is a rectangle. And so I can say that AB squared plus 9 squared equals 22 squared. So AB squared plus 81 is equal to 22 squared is 400 and something. 484. So AB squared is equal to 403. So AB is equal to the square root of 403. And I like precise answers. I'm actually going to leave this as square root of 403, although you could also say it's approximately 20.07. All right, now we're going to look at angles. ADC, well, that's an interior angle of a rectangle, so that's 90. That's easy. BAC, they told us that BCA is 66. Okay, so if that's 66, and I know that the interior angle is 90, that means this part is 24. So 24 and this one up here are alternate interior angles, therefore that's going to be 24 CGB, this one over here. I know that the diagonals are congruent and they're bisected, so this part EC and this part ED are congruent, making this an isosceles triangle. So if that's 24, so is that. CDB. And lastly, AEB. Okay, if that's 24 and that's 24, then I know that the third angle, this one here, has to add up to make 180. So 24 plus 24 plus x equals 180 because it's a triangle. So 48 plus x equals 180, so x equals 132. So this angle is 132 degrees. Continuing with our rectangles, we have PR is 9x plus 1, and QS is 13x minus 12. All right, those are both diagonals. Diagonals are congruent, so I can set them equal because PR is equal to QS. That means that 9x plus 1 is equal to 13x minus 11. Subtract 9, add 11, so 12 is equal to 4x, x equals 3. They're asking us for TR. So TR equals 1/2 of PR. PR is 9 times 3 plus 1. So we'd be doing half of that. So 1/2 of 27 plus 1 is 28. So that'd be 14. Last rectangle. If it's a rectangle, then the measure of DEG is equal to 4x minus 5, and FGE is equal to 6x minus 21. Well, those are alternate interiors, so those should be the same. So 4x minus 5 equals 6x minus 21. Subtract 4x, add 21. 16 is equal to 2x, x equals 8. They're asking us for DGE. Well, if I plug this in here, I can find that 6 times 8 plus minus 21 is equal to 48 minus 21 is equal to 27. So if this part's 27, I know that the measure of angle DGE is equal to 90 minus 27, which would be 63. So DGE is 63 degrees. Now we're looking at rhombus and square. This is a rhombus. We know that the angles are bisected, so JKL would be 36 times 2, which is 72. MLK, well, this angle and this angle are supplementary, because even though it's a rhombus, it's also a parallelogram. So we'd be saying 180 minus 72 leaves 108, so MLK is 108. JMK, so it's just this one here we're looking for. Well, that's an alternate interior angle with that 36, since these lines are parallel, that's going to be 36 degrees. And MJL, So this is the one we're looking for. Since this is 108, and we know that the diagonals bisect the interior angles, this one is being cut in half. So that's 54 and that's 54. So that's 54. K, K, N, L. Any rhombus has a 90-degree intersection of the diagonals, so that's 90 degrees. Using from the previous question, if Mn is equal to 20 and Jl is equal to 26, find Jk. Okay, so what they're setting up for us to see is that Jk and N. And if Mn is 20, then so is this. And if Jl is 26, then this is half of that is 13, and we're looking for x. This happens to be a right angle in a rhombus, so it's a Pythagorean theorem. 13 squared plus 20 squared equals x squared. 169 plus 400 equals x squared. 569 equals x squared. I don't think that's a perfect square. So Jk equals square root of 569, which is about 23.85. All right, another rhombus, and we know that these two angles have been bisected, so this half is the same as this half. Those are equal. 9x minus 43 equals 5x plus 1. Subtract 5x, add 43. X is 11. It wants SVU, so I'm going to have to find one of these angles and double it to find the equivalent of this whole angle. So I'm going to say that measure of angle SVU equals twice the measure of angle STV. So that would be twice 9 times 11 minus 43, which would be twice 99 minus 43, which would be twice 56, which is 112 degrees. Now we're going to say ABCD is a rhombus. If AD is 4x plus 2, and DC is 7x minus 13, and BD is 34, find AE. Okay, if BD is 34, then that makes this 17. If I knew this side length, I could find that using Pythagorean theorem. Oh, because it's a rhombus, these two sides are the same. So 4x plus 2 equals 7x minus 13. Minus 4x plus 13, 15 equals 3x, x equals 5. Which means that 4 times 5 plus 2 is 22, and that would be the same as 35 minus 13, 22. Yep, the side lengths are 22. So for me to find AE, I'm going to be looking at this right triangle. Here's A and E. This is 22. This is 17. I'm looking for x. So I'd say that x squared plus 17 squared equals 22 squared. X squared plus 289 equals, I did this before, 44. So x squared equals 195, which means that x, which I called AE, is the square root of 195, which is about equal to 13.96. Now it's a square, so that means it has all the attributes of a rhombus, a rectangle, and a parallelogram. So WXY, well that's 90 degrees, that one's easy. XZY, XZY. I know this whole angle is 90, and because it's a rhombus, it's been bisected, so that means these have to be 45 degrees. Angle YXZ, YXZ. Well, if it's a square, these two sides are the same, which means this is isosceles. So if that's 45, so is that. WRZ. Well, in any rhombus, the diagonals are perpendicular, so that's going to make that 90 degrees, and XWY. Again, it's a 90-degree angle that's going to be bisected, so that's going to be 45 degrees. Using this square, if WY is 32, find XY. So they're suggesting that if this is 32, and I know that this side, I don't want to use X because X is already in there, I'll put an A in there, and this side are the same, and that's a right angle. So that means that A squared plus A squared equals 32 squared. So 2A squared equals 1024, which means A squared equals 512. So A is the square root of 512. That's that side, which is the same as XY. So we could say square root of 512, which is going to be approximately square root of 512, 22.63. Now we're into trapezoids. This is not an isosceles trapezoid, just a regular old trapezoid. So these two have to be supplementary. 180 minus 104, that makes this 76. And this one is going to be 180 minus 41, that makes that 139. So angle Q is 139, and angle S is 76. Here's another one that's not isosceles, it's just a regular old trapezoid. But I know that since these are the parallel lines, this is my river, this is my bridge, therefore these are same side interior, those should be supplementary. So 5x plus 26 plus 8x minus 2 equals 180. They're supplementary. So 13x plus 24 equals 180. 13x equals 156. X is equal to 12. All right, 156 divided by 13. 12, yes. So if that's 12, then the measure of angle H equals 8 times 12 minus 2 is 80, 96. 96 minus 2 is 94 degrees. Over here, we're dealing with isosceles trapezoids. So we know that the base angle is the same. So if that's 117, so is that. And these are still supplementary. So if I say 180 minus 117, I get 63. And the base angles are congruent that way as well. So both of those are 63 degrees. Lastly, these are base angles, even though they're on the top. Because these sides are the same, these angles will be the same. So I'm going to say 8x minus 23 equals 6x plus 11. Subtract 2x, add equals 34, so x equals 17. I'm looking for angle M. Well, I got to find one of these, and then I can do supplement. So I'll say the measure of angle J equals 8 times 17 minus 23, which is 80 and 56. 8 times 17 is 136. Minus 23 equals 113. But I need angle M. Measure of angle M equals 180 minus 113 equals 67. So M is equal to 67. That takes care of the first 3 pages of the review.